Welcome back to Engineering Essence. Today, we are diving into an essential topic for electrical and power system design: electrical load lists. In engineering, load lists aren't just a set of values, they're the backbone for reliable, efficient, and safe power distribution. This video will break down the key terms, standards, and formulas you need to create accurate and effective electrical load lists. Let's get started. When preparing an electrical load list, it's essential to describe each load accurately. Typical categories include motors, lighting systems, HVAC, and specialized equipment. Each type has its own characteristics, and a clear description helps engineers choose the right power sources, ensure safety, and prevent overloading. Load types also influence installation needs and maintenance requirements. Think of this step as laying the foundation for everything that follows. Next up is power requirements. We have two main terms here: rated power and absorbed power. Rated power is the maximum amount of power equipment can handle under continuous operation. Exceeding this can lead to overheating and equipment failure. Absorbed power, on the other hand, is the real power consumed during actual use. Calculating absorbed power uses this formula: voltage x current x power factor. This helps in accurately sizing equipment and preventing system inefficiencies. Voltage and current are crucial specifications. Rated voltage represents the optimal operating voltage, while current rating refers to the required current. Ensuring compatibility is critical here. Then, we have power factor, a measure of power efficiency. High power factors are ideal because they indicate effective energy use, while low power factors can mean wasted energy. Keeping a balanced power factor can enhance system efficiency and reduce operating costs. Duty cycle classifications like continuous, intermittent, and short-term duty describe how equipment operates over time. Continuous duty might mean around-the-clock operation, whereas intermittent duty involves periodic use. Understanding these cycles is key in designing systems that last. It impacts everything from component selection to maintenance schedules. Moving on to efficiency, utilization factor, and demanded power. Efficiency tells us how well a device converts input power into useful output, which is critical for optimizing energy use. Utilization factor measures if equipment is underused or overloaded. High utilization shows efficient resource use, while low utilization may mean you are investing more than necessary. These factors, along with demanded power calculations, give engineers a roadmap for efficient system design. Phase types, single-phase versus three-phase, also play a big role. Single-phase systems are simpler and ideal for smaller loads, while three-phase power is common in industrial settings for stability and efficiency. Choosing between AC and DC power supply also depends on compatibility with system requirements. It's these details that ensure equipment longevity and avoid unnecessary power losses. Then we have environmental considerations like temperature and IP protection ratings for dust and water resistance. Mounting and installation requirements are also essential, ensuring the equipment is safely and effectively integrated into its environment. These factors can impact both performance and durability, so they're not to be overlooked. Standards such as SAES and NFPA 70 provide guidelines for creating accurate and safe load lists. For example, SAES outlines criteria for duty classifications, power supply, and rated voltage, while NFPA 70 sets requirements for motor duty cycles, power factor, and phase selection. These standards bring uniformity and ensure that the designs meet safety and reliability benchmarks. Let's recap some of the key formulas and calculations. Absorbed power, load factor, and utilization factor are all critical to accurate load planning. Absorbed power equals voltage x current x power factor. Load factor is the ratio of average load to peak load. And utilization factor tells us how effectively equipment is used. These calculations lay the foundation for efficient and safe system designs. To wrap up, a well-prepared electrical load list ensures that every component in your system is optimally sized and operates safely. From accurate power descriptions to careful attention to standards, every step plays a part. I hope this guide helps you understand the importance of detailed load lists in engineering. Don't forget to like, subscribe, and stay tuned for more deep dives into engineering essentials.